Hello everyone, I'm Dr. Vishal, Assistant Professor, Department of Physics, Swaminarayan, Senior College, Matta. Today, in this session, we will going to discuss the photoelectric effect. So, friend, let's get started. Photoelectric effect. When light energy in the form of photon or particles strike on a metal piece or metal place with sufficient energy, then electrons are ejected or emitted from the surface of metal. This effect is known as the photoelectric effect. Now let's see how this happens. Figure is shown here. Uh, a metallic piece is taken. Also, a source of light is present over here. When light is allowed to incident on the surface of metal, then electron from the surface of the metal get ejected. Find this electron ejected electron known as photoelectron because these electrons are uh, these electron these ejected these electrons ejected by the action of because this electron is ejected by the action of photons. Now the question will arise that light of any energy can be ejected photoelectron from the surface of the metal. So the answer of this question is no. Basically, each metal has a certain work function. This work function is nothing but the minimum energy which is required by the electron present in the surface of metal to get ejected from the surface. Fine. So the quantum energy or the frequency of the photon must be either or equal or greater than this particular work function in order to have photoelectric effect. Friends, certain laws are associated with the theory of photoelectric effect. So let's move the further order to understand the three laws of photoelectric effect. First one is we have certainly discussed the first law. Is that photoelectrons are ejected or emitted by the surface of metal only when the frequency of incident light or radiation becomes either equal or greater than the work function of the metal. Of the metal. Here, pi is represent the work function of the metal. H is the Planck constant, and F is the frequency of the incident photon. And we have already discussed the reason behind this particular law. So let's move further toward our second law. Friend, this law take that the number of photoelectron emitted per second is by the metal surface is directly proportional to the intensity of incident radiation. And one incident photon on the metal can eject only one electron from its surface. Our third law is that the kinetic energy of photoelectron is independent of the photon intensity of dependent of incident radiation, but it is dependent on frequency of component of light. Now the question arises: what is the kinetic energy? So we know that sometimes the energy of the photon is more than work function of the metal. So the extra energy is utilized by the immediate electron as its kinetic energy. Hence, with this effect, Einstein photoelectric equation is associated. So now it's have to look toward that. We know that the quantum energy is the energy light particles. Okay, and it is given by quantum energy is given by W is equal to h. Here h is the Planck constant and f is the frequency of incident photon. This we have already discussed. The value of this Planck constant is nearly around 6.626 into 10 raised to minus 34 joules second. Also, the work function of the metal is denoted by pi. Also, this work function is denoted by pi is given as h f naught, and this f naught is the minimum. This f naught is the minimum frequency which is required to cause the photo emission. This f naught is sometimes termed as a threshold frequency of the meter. Also, the kinetic energy of electron is given by the difference between the quantum energy and work function. So basically, the kinetic energy of photoelectron is nothing but the extra energy, which is achieved after subtracting the work function from quantum energy. So on subtracting the value of quantum energy and work function in this particular equation, we will get another equation, that is the kinetic energy is equal to hf minus hf naught. Also, we know that kinetic energy is given by half mv square equal to hf minus hf naught. On transposing quantum energy to the LHS side and kinetic energy to RHS, we will get this particular equation, that is HF is equal to half mv square plus HF naught. And this particular equation is known as photoelectric equation. So this is all about photoelectric effect. Well, friend, this brings to me the end of this lesson. I hope you will find this lesson is very useful. Thank you. Thank you for your kind attention.